only care about the dimension of this quantity. And if A equals this thing, the square of this thing equals the square of that thing. And the dimension of this thing will be the product of individuals' dimension. Make sense? So L1 has dimension of length. L2 also has dimension of length. So together, area has dimension of length squared. So that's how you can just derive the dimension of any quantity based on their definition. You don't need to memorize the dimension of all quantities because you should be familiar with this such that you can derive any quantity's dimension in like 10 seconds, okay? So that is area. And it works the same for all areas. Let's say you're not computing the area of a rectangle, but you are computing the area of my face for some reason. No matter what answer you get, that answer must have the dimension of length squared because it's the area. If you are doing like a circle, you have pi r squared. The pi is just a number, so the dimension of pi r squared is still length squared. And that is true for all areas. The power of dimensional analysis is that you don't need to know the detail in order to have a sense of whether the answer makes sense or not. So let me give you another example of combination of dimensions. You see, even though area is not length, it's not time, it's not mass, but it's just a square of length. So you can build up the dimension of anything with just length, mass, and time. Let's say you are driving your car 60 miles per hour on highway. We will say that your speed is 60 miles per hour. And we can look at the dimension of 60 miles per hour. Again, the dimension of this thing is just putting a square bracket around it. And you can just put a square bracket around the individual thing, around the numerator and the denominator. Okay? And when you look at the dimension, it doesn't matter if you're driving 60 miles or it doesn't matter whether it's 60 or 70. The number doesn't matter. The only thing that matters is the type of quantity this is, which is a length. 60 miles is a distance, it's a length. So the numerator is length, and the denominator is time. So we can write it as L times t to the power of -1. Something to the power of -1 means 1 over that thing. Does that make sense? Okay, good. So you see, any quantity you can ever imagine will all be the convention, will all have the dimension of the combination of length, time, and mass. Okay? By the way, for some reason I think it is a good idea to have 2.5-hour lecture. I will give you a 10 minutes break for every lecture, so in the middle of it, but it's still like 1 hour each. Okay? So dimensional analysis gives you a basic sense of whether your answer makes sense or not. For example, you should never compare things with different dimensions. If you are comparing two quantities, then those two quantities must have the same dimension in order to compare them. Like, I can say my sister is 5 feet tall. I am 200 pounds heavy. Who is older? this question makes no sense because I'm describing some time, I'm describing some mass, and I want to compare our time. It doesn't make sense. You can only compare things with the same dimension. You can compare length with length, you can compare two people's height, you can compare two people's age, but if you say one people is like 10 years old, one is 100 pounds heavy, you can't do anything with those two quantities. So this is the biggest difference between mathematics and physics. In mathematics, you just care about numbers and you do whatever you want for the numbers. You can compare 10 with 100, no matter what. But if you are doing physics and that 10 stands for 10 years old and 100 stands for 100 pounds, then there's nothing you can do by comparing them, okay? It just doesn't make sense. So that is very useful because practically you will do a lot of algebra in this class. I hope you are already seeing that coming. And when you do algebra, it's easy to make mistakes. Dimensional analysis gives you an easy way to just spot your mistakes. Let's say you are not having a good day, you drank too much last night, so you make a mistake on computing the area of a square. I know you guys are smarter than that, but let's just take that as an example. Let's say you are doing a math question saying that the area of the square has equal sides, and the problem says that the area of the square equals the area of the circle with radius r. So they want to ask you like what's the ratio between the side length of the square and the radius of the circle. And then you know, aha, I just write down the relation of area and the side length. And for some reason you wrote power of 3, and you equate that with pi r squared. Now, if you learn dimensional analysis, you're fine because once you look at it, you will say, wait a second. The left-hand side has dimension of length cubed. The right-hand side, pi r squared, has dimension of length squared. There's no way these two equal to each other because they don't even have the same dimension. Then you go back and figure out you did a stupid. It should be length squared instead of length cubed. Okay? I know that's a elementary example. Let me do something that is more practical. So anyway, dimensional analysis can easily help you to spot that something's wrong, and then you can go back and fix your mistake. If you ever see some quantity equal to each other having different dimension, and you know that's nonsense and something was wrong in your previous calculation. So what I'm going to write down is something you will write down after the midterm. So it's not going to happen within 2 weeks. Don't be scared about it. In 3 weeks, you might write down something like this. Don't worry about what is G. M is some mass. R is the radius of some stuff. And then you are doing your physics homework, so you need to do some algebra, and you came up with this equation. Don't worry about what I and alpha is, but from now you should try to learn how to pronounce Greek letters because we use them a lot. Do you guys know alpha? Okay, so if you don't know alpha, there's a appendix in my book which has all the Greek letters and how to pronounce them. Make sure you do that. If I heard you say A, and I will be mad, but I won't do anything to you, but I will be mad. So this is alpha. For now, you don't even need to know what alpha is and I and g. Because just by looking at this equation, you see that the dimension of this thing is the dimension of mg, whatever that is, times the dimension of half r. The dimension of this thing is dimension of mg times r squared. And you are subtracting them. I don't care what dimension of I alpha is, because I can already tell these two terms have different dimensions. This is the dimension of mg times the dimension of half radius, which is a length. Radius squared has dimension of length squared. So there's no way these two terms has the same dimension, and it makes no sense to subtract them. And then you can go back and see, so if you are in the future right now, 3 weeks later, you can know what the dimension of I alpha is, then you can figure out which term is the wrong one. But so far, you already know how to judge yourself in the future. If you go to the future and you do your homework, you can already check the answer by dimensional analysis and say which part is wrong. You don't need to know anything about the detail of this system. You can already say something about it. That's the power of dimensional analysis. Okay. So anyway, if you see you are adding or subtracting something with different dimension, then something must be wrong. Yeah. Again, something is wrong. So one last bullet point for dimensional analysis. In this class, you might need to use trigonometry. You guys know that? Trigonometry, sine, cosine, tangent, cotangent. Second. So when you write out some function such as sine of x, when you write down a mathematical function, it is from the Department of Math. It's from those mathematicians, so they only care about numbers. The thing you put inside this sign must be dimensionless. A number, a quantity can have no dimension, which we say the dimension is 1. Make sense? 1 has no dimension, so if you're looking at a dimensionless number, then the dimension is 1. And if you want to put a number, a quantity, into a sign, that thing must be dimensionless. So you might write down something like sine. This is called omega. You will learn that in your future. You can write out sine of omega times t, which omega t has a dimension of t minus 1. That's the dimension of omega usually. Omega usually means something with dimension 1 over t, and t is usually for time.